Hey, it's 11:01. We should probably get started.
Let's do that.
Is that okay with everybody? Cool.
Yeah, let's get rolling. So first question was, why did you sign up? Second question was, what type of pallets or dunnage or totes do you deal with? This one, maybe A, B, C, D, E, F, if you want to answer this one.
Yeah.
You know, what kind of manufacturing process do you use to make pallets? There's a lot of different ones out there. Generally, like a single shot injection mold, there may not be welding on that. There may be, but maybe in a specific application. There's the two-shot injection mold, which we're going to talk quite a bit about because that's primarily what we do when you see the most volume. We've been seeing a little bit of growth in the area of twin thermoformed sheets because I think that they offer a little bit more impact resistance when you're dealing with that. The thing is, they don't always offer the opportunity to have a raised rib for you to weld on. We also look at an injection molded base with an extruded top. And, you know, maybe you're doing some hot plate welding, maybe you're doing something else. So please let us know if you have something there. Otherwise, we're going to try to run the gamut and cover those things. Right, Jason?
So a quick housekeeping issue. So we don't want you to save your questions to the end. We want you to ask the questions that you have when they come to mind. So please type those in as they come up, and then we will do our best to answer them in the moment. If you're anything like me and you have a question, you stop hearing the presentation and you can't get the question out of your mind. So please ask those as they come up, and we'll do our best to have a good dialogue.
Yeah, sounds great. So I'd like to talk a little bit about why X-Toll. When you look at plastic welding, that's our sole focus, right? Plastic welding and joining, and we'll talk about that. Comes in a couple different shapes and forms. We'll also talk about what that looks like. When it looks like, when we talk about those different applications that we've looked at, right? There's pallet welding, which is that two-piece injection molded piece that we look at. We've done bin extension. So when you have a bin and you want to add some height to that, there's also been pallet extension. We've looked at some bin extensions on a lateral approach too, but then there's also the tote reinforcement. So sometimes you may have a standard tote that you're making and you want to reinforce that bottom because it's got heavier materials that are being transported in it. So that's another way that we look at welding for those different types. Yeah. And you might have something else that you've got. So, you know, I encourage you to talk about that. Again, as I said, X-Toll solves complex plastic manufacturing challenges, and that kind of X in the logo there on the side talks a little bit about our approach. As I said, we really focus on plastic welding expertise. At the core, that's what we do. We also have expertise when it comes to custom automation, but really the value you get is we've got, you know, a standard piece of equipment. When we need to solve those tough plastic challenges, we've probably got a piece of equipment and we've definitely got a process that we can take you through to figure that out. When you look at equipment, we can custom tailor that equipment if it doesn't fit inside a standard hot plate welder like this one here on the left. So we can do that piece. So really what X-Toll does is we don't make you compromise, right? We give you the best of both worlds when we're working with that. And our approach is kind of threefold.
Yeah.
Right.
We got a quick question from Ted. Can heat welding create an airtight or watertight barrier?
Great question.
Absolutely. A lot of different welding methods can create a hermetic seal, something that's airtight or watertight. And hot plate welding is definitely one of those. So we'll quickly talk through some of these areas that X-Toll specializes in. Our engineering services group, think of us like an extension of your engineering team. We can help you with development. We can kind of guide you through the process of adopting plastic welding into your manufacturing processes. So we can help you with prototyping, validation. We'll do a design of experiments, whatever you need, and we'll guide you through that process. I'm going to quickly touch on the different plastic assembly technologies that we offer. They actually split up into two categories: welding technologies and staking technologies. When we say welding, what we're talking about is taking two plastic materials and getting them to bond at the molecular level. That's welding. Staking is a mechanical joint. So we're heating a post and we're forming that to capture some mating component. So it's a mechanical retention, doesn't require material compatibility. It can be, staking plastic to something other than plastic, like metal or paper or leather, or, lots of different options, printed circuit boards. But today we're really going to focus mostly on welding. I'll quickly just give a high level overview of some of these different technologies. A few of them use infrared energy. InfraGuide is focused infrared energy. Quartz IR is a more broad-based infrared, where we take a mask and use that to block off areas of a part where we don't want to get heat. Laser welding is a very focused single wavelength of infrared energy that we trace around a part to get the weld. Infraweld is a focused spot weld that does through transmission with IR. And then the main focuses of today would be hot plate welding. So hot plate welding, we'll get into the details of that, but essentially you have a heated tool and you're touching plastic to that. And then the last one that I quick glossed over, spin welding. You spin one component relative to the other, apply a pressure, and that friction of the spinning motion causes the plastic to heat up.
And a quick comment from Ted. He's like, is staking similar to a concept to a rivet?
Yes.
Exactly. Right?
Yep.
You've basically got a boss that pierces through one part, right? You're heating up that boss, and then you're using a punch to form a rivet-like head on top of that for that mechanical retention. That's exactly right.
Yep.
And in that staking, right, Jason, we have infrastake, which is using IR energy, right? And then you got nanostake, which is actually got kind of a thermal heated puck that allows you to do that.
Yep. It's like a smart respond heating system that rapidly heats and rapidly cools down.
Right. So when you look at equipment solutions, we can do a standard piece of equipment. We have some of those in inventory here in our shop, different size hot plate welders, but we can also do IR welding with that. We also have our standard integration for our staking, which you see there, the infrastake. So that's something that we do with integration in many applications. We probably do more of that with staking than we do necessarily with hot plate or IR, but we still do quite a bit there. And then we do that custom automation, but we'll do custom automation only if it's really around a plastic joining process, okay? Doing a custom piece of equipment or a little bit of automation around that makes sense, but that's not our core focus. Our core focus is solve the plastic problem.
Yeah.
Right? Any other questions? Pause for just a second. So we're going to talk a little bit about hot plate welding. We're going to start right there. We're going to talk about what it is, how does it work, what are the benefits, where is it used, and how to design for it, and then what does the equipment look like. And then what we'll do is we'll talk about how some of those other technologies can operate in that same equipment and why we might use those as an alternative. Right, Jason? Okay. So plastic welding, you need two things. Pretty simple. You got heat and you got pressure. That's it.
Yeah.
Pretty simple. Done.
There's lots of different ways to apply that, as we kind of looked at in the overview of all the different welding technologies, but heat and pressure. That's it.
Okay.
So what is hot plate welding? It's a contact joining method. So we're actually touching the plastic to a heated tool. Here's your heated tooling plate. That's what that little red rectangle is meant to represent. So that's hot, and we can control the temperature. And when we touch onto it, the conduction from the heated tool goes into the plastic parts. And then once things are heated up sufficiently and you bring them together, you get strong leak-proof welds. Just like Ted was asking, yes, they are strong, they are airtight, they are watertight.
Yeah. We talk about some of those bins, right? When we talk about welding some of those, one of the applications we had was a vertical extension on a bin, and they were actually putting fluid inside of that.
Yeah.
So absolutely, we can get that to work in even that large scale type application.
And as many of you probably know, there's, if you put a bunch of fluid inside of a Dunnage sized bin, there's a lot of pressure involved with that. And so it's got to be able to hold a lot of pressure.
Yeah.
So here's a quick video showing just what the hot plate welding process looks like. This is not a pallet, much smaller than a pallet, but this illustrates the hot plate welding process.
Polypropylene?
Yep, this is a polypropylene part. The heated tool here is probably around 800 degrees Fahrenheit. It's a quick melt time because of the high temperature. And then this is the seal phase where we're pushing those plastic parts together to get a bond. I saw somebody start typing. Did you have a question? Because feel free to ask it whenever you would like. How can you ensure that the weld will hold up to the impact from pallet jacks? Oh, that's a good question. So what we typically do, the testing that we can do is tensile testing, and we make sure that the weld is really, really strong. Hot plate welding, you can typically expect to get anywhere between 80 to 100% strength in the joint that you would expect from the parent molded material. And if you are, oftentimes what we have people do is design the weld rib width to be a little bit wider than the wall thickness of the rest of the part. And that way, if your weld strength is more in the 95 to 90% range, the extra thickness in the rib will get you to the 100% strength. So if the wall thickness is strong enough to survive the impact, then the weld joint should too. Most of the time when we do strength testing on plastic welded parts, the joint doesn't fail. Somewhere else on the part breaks apart.
Yeah, parent material, right?
Mm-hmm.
Yeah.
So here's a quick overview of the hot plate welding process. Like we've seen in the previous video, you apply the heat by touching the plastic to the tool. There's an open phase in between where that heated tool is getting out of the way. And then a weld phase, or sometimes we call it a seal phase, where we're bringing those parts together, applying controlled pressure to get those to bond.
And that's the cooling phase, right? Get it in contact, let it start to cool.
Yep.
And then move on.
Yep.
Yeah.
So there's lots of different parameters here, but some of the main important ones are you want to control the temperature and the depth and how long you're in contact with the heated tool. That is affecting how much heat you're putting in. And then you have the seal or the weld phase where we can control the depth, how far we're pushing those parts into each other, the forces that we're using to do that, and how long we're holding it. That's all the pressure parameters that really matter the most. I see Mike typing.
Yeah.
I don't want to jump too far.
He's got a long one. This could be a long question. That's good.
We'll let him keep typing.
Yep.
Benefits of hot plate welding. Welds are strong. As we were talking about, you can get basically parent material strength. Leak proof, so that'll hold water, hold air, hold lots of other fluids as well. Doesn't have to be water. But it's also no particulate. There are other processes that join plastic parts where there's, usually when you're having a friction-based process, that can generate particulate, which means there's plastic fibers and loose particulate coming off of the weld joint. Not an issue for some applications, but in some, you would need a cleaner assembly, and particulate's a bad thing. So hot plate welding doesn't have any particulate.
And it's generally speaking, when you're looking at hot plate welding, because of that molecular exchange that's happening, Jason, right? It's really the strongest weld you can get.
Mm-hmm. Yeah,
it really is.
It's a very strong, robust weld. So one of my favorite things about hot plate welding is that it normalizes the weld joint. Now, this is going to explain why we're able to get strong parts, why we're able to get hermetically sealed joints. If you guys are all making plastic parts, I think. And so you probably know that if you look close at a plastic joint or a plastic part, they aren't actually flat. There's always warp or inconsistencies in the final plastic part that deviate from the designed plastic part in CAD. And so how do we deal with that? Well, the hot plate tooling can be machined to be very flat. So hot plate welding, you use the hot tooling to normalize or flatten the weld surface. And we're doing that on both sides. So what you end up with are two parallel surfaces that are flat and ready to be joined. Now there's no high spots, there's no low spots. So when we bring these two surfaces together, the pressure that we're applying to the joint is evenly distributed along the entire weld surface. So you know you're getting strength everywhere and you're getting leak proof everywhere. Mike has a question.
Yeah, Mike has a question there. So you want to take that one, Jason?
Is there a way to simulate via FEA or similar process the rackable strength load carrying ability of a welded pallet? Boy, there might be. I'm not sure. I would think there is, but I'm not sure exactly how you'd go about doing that. I think you'd have to make some assumptions as to what kind of strength the actual joint is seeing. Yeah, that's a good question, Mike. I'm not quite sure the answer. I know we have not done FEA on a welded pallet. We're always doing, we do some estimates of strength, and then I usually apply a safety factor, and then we back that up with testing parts,
Yeah.
actually physically welding parts, and then doing
we could
tensile
weld
tests.
and take a segment of that, right, and then do a tensile test on it,
Mhm.
give you an idea of what that is.
Yep.
But I don't know that we've done that, and I think that when you look at rackable strength and load, I'm thinking about, some pallets do require a rod to be inserted, a steel or fiberglass rod, which then increases the strength of that, transferring the load when it is in a rack from rail to rail.
Yeah.
So I'm not sure if that's part of what you're talking about there, but we do weld pallets with rods. And when we talk later about kind of cell automation and what that layout might look like, we'll talk a little bit about rod insertion there.
Mm-hmm. Wait for him to type. He's typing.
Good. Well, keep going here, Jason. We'll pause.
Okay.
He's got our attention. You got our attention, Mike. Bring it on.
Love the questions.
Yeah, absolutely.
Agreed on the rod insertion, just wanting to avoid this if possible. Oh, yes, yeah. Yeah, well, so what I can say is welding plastic parts will never increase beyond the strength of the original material. So you can't get 105% parent material strength. You can only get 100. That's the max. So if plastic is going to bow under the weight of the load of whatever's inside of it, you've reached the limit of what the plastic can do, and then you've got to do some other reinforcement, whether that's more plastic reinforcement ribs inside, or whether it's inserting other materials that are better at bend strength.
Yeah, and I can also understand your point on the rod insertion and wanting to avoid that, because it does down the road, right, for that pallet, it does affect the way that you can regrind that pallet if you want to make that more sustainable.
You got to disassemble first.
It's hard to disassemble those. Right? They're kind of complicated. So, great question, Mike. Thanks very much for that one. Common materials we're looking at, right, is really polypro and HDPE, right? So sometimes people put fillers in that with glass or talc, right? But we've done both of those. We'll talk a little bit later about temperatures too. So polypropylene, you could go with a little bit higher temperature, but when you're dealing with HDPE, you're really going to have a Teflon coated tool. People don't like to necessarily coat the tools with Teflon, but you've got to approach it at a lower temperature, and also you've got to worry about a little stickiness with that, right?
Yeah. Is anybody on the call using a material that's different than polypropylene or HDPE? I'm curious if there's any materials that I'm not familiar with, maybe Rob's familiar with, that you're using in your plastic pallets that are not polypropylene or HDPE. Let us know.
Yeah, this is a good way to talk about really, as we're gonna talk about hot plate and how this works and kind of the transfer of energy in the various phases. But then we're also going to talk a little bit about IR. We'll talk about those differences. So, Jason, let's talk about this here.
One of the biggest differences between using hot plate welding to weld and IR to do your welding is that material displacement. How much material do you need in your weld joint or in your plastic that's going to get moved out of the way? So with hot plate, when you reach the melt phase, we're displacing some of that material. We're melting some of it away. So what you see on the screen, the stuff that's in orange, actually, I think I can highlight it with my little laser pointer. Yeah. So if you look at this area here, the little yellow area is showing, okay, that material was there, but now it's been pushed out of the way by the heated tool. So you'd get like a little ball of plastic on either side of the weld rib. Then you go to the open phase, that little shaded yellow area still not there in the joint, and then you come together in the weld phase, and now we're squeezing out even more material. So the total displacement here is a fairly significant portion. For something like a pallet, you're probably going to displace 2-3 millimeters, maybe more, of material just because it's a large part. And as we talked about, with hot plate, you're normalizing that weld surface. So if you've got a lot of inconsistencies in the surface of your part, we have to melt all of those away. And so we melt a lot of displacement to get to all even total melt on the whole surface.
Yeah. And then that radiated area there, that's really that heat effective zone, right? That's actually where you're going to get a lot of good bonding.
Yes. So all of this area is not displaced yet, but it's been warmed up. It's been affected by the heat, and it's ready to be bonded to the other side of the part. All right. So how does that differ from IR? So let's quick show a video of what infrared welding looks like. This is So you can kind of see, once it lights up, you can see there's all these quartz bulbs that are emitting that infrared energy. And then in the middle here, like this area, that is the mask. That is a piece of tooling that is designed to block some of the infrared energy from getting to the plastic part. That way we
try to direct it on that weld rib.
Yes,
right?
Exactly. And this is blurred out for customer confidentiality, but you can imagine what that would look like on your pallet.
And so, Jason, why would somebody want to go to an IR option instead of a hot plate option?
So there's two main reasons that I could see. One is you're trying to reduce the amount of displacement that you have, reduce the amount of material that you're displacing. But the second reason, and maybe the bigger reason, is sticking issues. If you're having trouble with the plastic from your pallet sticking to a heated tool, then the best way to get rid of that is to don't touch it with a heated tool.
Yeah. So on the far right here, when you look at quartz IR, the heated area may be different. It may be perimeter, right? And that if you think about that quartz IR tube, right, you can shape that around your weld joints. If you wanted it round, you could do that. Rectangular, you could do that, right? But with hot plate really comes in two different formats. You could do the total surface area, right, which is the one on the left, or you could do these, I'll call it pucks, so to speak, that might line up with your legs that might be on that pallet. Whereas the other one, when you're dealing with quartz, you're dealing with IR. Those bulbs are probably more expensive, and they also do consume quite a bit of energy. So you want to try to limit the amount of space that you're trying to cover. You don't want to wash the whole part in a pallet. Let's face it, it's a lot of real estate.
Yes,
right?
Exactly. So here's what the material displacement looks like in IR welding. Now you had, instead of a heated tool, you've got an IR emitter, and in the melt phase, we're not displacing any of that material. We're just using the infrared emitter to create that heat affected zone. And then in the open phase, there's no material displacement, and only you're only displacing material in the weld phase. So the amount of displacement is basically cut in half. If you compare this slide to the hot plate welding displacement, you can see the total displacement here is quite a bit bigger, and then the total displacement for IR welding gets reduced.
And you could still work with a rib joint on this. Again, why people would probably do this is because they don't want to be in contact, right? But it's just an option for you, and you may have other applications. You say, oh, that'd be kind of interesting. I'd like to talk about that. That's what we do when we talk about the engineering services. Let's look at your design, figure out what the right application is, and then apply that application to the situation. And we also have some situations where we look at and people say, hey, ultrasonics, maybe we could just touch this off on a couple legs for us to do that. So that's also an opportunity, but that's what we want to discover with you when we're trying to figure out what are you trying to accomplish.
Which is better for a high volume of weld surfaces, hot plate or IR? That's a good question. I would say the amount of power and energy that you need to heat up and maintain the heat on a hot plate welder is lower than what you need on an IR welder. The amount of energy that goes into the bulbs for IR welding is pretty high. And so I would say your probably best bet is to go with hot plate welding if you have a large weld surface. So this slide here is sort of meant to illustrate that. In hot plate welding, the one on the far left where the whole surface is a hot plate, a hot tool, that's doable. If you were to do a pallet-sized quartz IR for something like that, you'd have to call your local power company and say, I need a new generation, a power generator right next to our building that will generate the...
And we'd introduce you to some of our friends in the energy storage industry. And,
yes.
Anyway, so...
Great question.
Yeah, good question. And it looks like Ted's got another one coming up, but let's keep moving here because we're 11:25. We promised these people they could have their lives back at 11:45.
Yes, we got 20 minutes to get through this. All right. So there's lots of different hot plate welding equipment that Extol produces. We produce anything from small modular welders that are made for welding, smaller components. We have our standard Titan series welder. How many of those do we?
Yeah, we've got probably 260 of those that we have sold. That's really where Xtol is really known for this. I mean, we got some of those that have 3 million cycles on them, and they just keep going.
Yeah.
And, the interchangeability of this, I think with the Titan, one of the things that we have done here too, this probably applies maybe to some of the tote conversation, Jason, is the way we've designed that is so that you could actually easily integrate that. So you could do a front traditional load on that with an operator load, or we could move off that front and put it in a manufacturing line with a conveyor coming through to pick up those parts. So it gives us some flexibility. And then the jumbo, right, is really when people came to us and they said, hey, there were some other people that were making hot plate welders for pallet welding. There were some European providers. There's some domestic providers that were really more automation people that were doing it. And people said, hey, you know about plastic joining. What can you do for us? And so we've produced multiples of this. We actually have one in our manufacturing facility right now that we're doing. And they come in a couple different options. And we'll talk about those in a minute.
Yeah. A couple questions here. At what point do these machines move past a standard 120 volt outlet for power requirements? I would say the only one that could maybe get by with 120 would be the small modular hot plate welder.
Otherwise, 2000 series in the
Titan, and that might even be pushing it. Usually we're going with 480 power from the get-go on all of these. Otherwise, the current draw to get to temperature and it would heat up so slowly if we didn't have enough power for it.
Yeah, that's a good point too. The thing is with hot plate, you've got to get those plates up to temperature, right? And you got to get those running for a while. And also you can look at hot swap on some of those tools if you need to change tools out, and we'll talk about that.
And once you're at temperature, then to maintain it, the power requirements come way down. The heaters are coming on and off just ever so slightly just to maintain the programmed temperature. But getting up there, you need 480.
And Willis has got a question there too.
What is the life expectancy of the bulbs on the IR? So I can speak to the life expectancy of our infrared bulbs that we use for infra guide, and the life expectancy is about 2,000 hours of on time. Now with a quartz tube bulb, I would expect something similar, but what we've learned from dealing with IR for a long time is bulb life consistency varies. So while you might be able to get 2,000, you might be able to get a whole lot more than that.
Yeah. And also it depends on really what the wattage of that bulb is and what temperature we're running to. We've done some tests with 100 watt bulbs, 150 watt bulbs, 200 watt bulbs. And the infra guide, the difference between that and quartz is one long tube, right, Jason? Yeah. But when you're dealing with infra guide, we use individual bulbs, and we can usually control the temperature a little bit better on that. But when you're looking at something like a pallet, you don't really need that fidelity. Right.
Yeah. Usually the joint is not so complex, and so you can get away with a more broad-based quartz emitter. Do the machines need to be at different temperature for room temp parts versus parts that are fresh out of a press? Interesting.
We'll talk a little bit about that in a second. I think when you look at Jason, right, there's some residual heat, right? So if you've got some whip that's built up and you've got cold parts, it's going to be a little bit different. But we can work on those process controls. When you leave Xtol, one of the things that's great is you leave with a recipe, and Jason's going to get really granular on this for you here in a minute, Ted. So great anticipatory question.
Yes.
I like that.
And then
we'll come to that.
Is there additional challenge with welding parts that are going to continue to shrink? I would say it usually doesn't. I understand the concern. It usually doesn't pose a problem because I believe the two parts that are your welding are going to shrink at the same rate because they're the same material most of the time.
Yeah.
If you have vastly different materials that are shrinking differently, then yes, you could, by welding them and then letting them continue to shrink, then you could get significant warp. One's pulling the other one. But usually we don't see that issue.
This is where Jason's really going to start to geek out.
This is where I'm going to nerd out.
Graphics and stuff. I like this part. So
buckle up.
We'll get into this.
With pallet, so it says pneumatic, but pneumatic or hydraulic is kind of what we're talking about. I know with the pressures needed for pallet welding, often it's a hydraulic machine. But the main difference here would be pneumatic and hydraulic welders need hard stops to control the the motions of your press. So there's stops that you have to mechanically, physically set. You can adjust the height of those. And then on a servo welder, there's no stops. So let's look at what happens in your weld process with a welder that has stops versus one that does not. When you come to the melt phase, you have a hard stop to control the height of your part as it presses into the hot tool. But how do you know that the whole weld surface is melted? With a servo-driven welder, we actually get feedback from the servo motor that we can calculate forces from. So in a servo motor, you can actually put a limit around the amount of force needed to get to your programmed melt position. And so if that force falls off or actually goes really, really high, if it's outside of the window that you know is giving you good parts, then you know there's an issue. Maybe you have a short shot, or maybe you had a part that had extra material flashed over on it or something. Something's wrong and you might need to look into it. Whereas a pneumatic welder, you don't get that feedback. If there's a short shot, it's going to go and it's going to hit the hard stops, and then it might not melt all of your part. Could be a problem. When you go to the open phase, welder with stops, you need to open it all of the way before you can get your heated tool out of the way. Things move a little slower in a pneumatic or a hydraulic machine. With a servo welder, you're able to program it to open just slightly, just so it's safe, and then you can get that heated tool zipping out of the way quickly because servo motors move fast. And then the weld phase. The question here is how much force is going into the weld joint? As we said earlier, heat and pressure. So how much pressure are you applying to the part? With a welder with stops, you're applying that force. Some of it's going into the weld, some of it's going into the hard stops. How much is going into the part? You don't know. There's really no way to know. You know that you're applying force, but if all of that force is going into your hard stops, then the part's not seeing any of it. With a servo-driven welder, 100% of the force being applied by the servo motor is all going into the plastic part. So you have control. Are you able to weld parts with a pneumatic or hydraulic welder? Yes. Is it a controlled, easy to understand process? No. But with a servo welder, you can. So here's kind of the summary. Pneumatic and hydraulic welders use stops. You can use electronic pressure regulators. It's great for simple, small parts, but with servo, you get no hard stops. You get precision control, fast cycle times. It's great for large, complex parts, and it's what we choose to go with for pallet welding.
And when you look at our pallet welders, I mean, it's kind of shocking. As I went out there, I was thinking that it really was only 4 servos. It's actually a 7 servo welder. And there's primary and secondary servos that are in that, right? Mm-hmm. But there's 3 for the horizontal motion, and then there's 4 for the vertical motion. So each of those platens has 2 servos on it, which makes sure you get, again, good uniform pressure when you're putting those parts together. And we know that's critical to the weld. So, let's keep going here, Jason.
So here is a video. We're not showing the part. Pallet. Spoiler alert. So you can kind of see how it moves around. The video kind of pans around the machine, so you get a little sense of the scale of this machine. And then you can kind of see as we pan in here, those are the heated pucks that are doing the melting on your part.
And so that green is the Teflon right on top of that, right?
Yep. So here's kind of a full dry cycle where we're doing a part pickup. So actually, I'm going to pause it real quick. I'm going to back up. So this part's important. That the lower tooling, what this welder was built for is we're loading onto that lower tooling, and by having it stick out of the machine, it's way easier for reach. Whether you have an operator that has to put these in, maybe you have 2 operators that put it in there. Trying to reach inside of a machine to load a pallet would be really difficult. So this is helpful for either manual load or a robot load where the robot reach can't get inside of the machine very well.
And this is a front load and a front unload in this application. We'll show another one that's drawing about.
So here it comes together, and that upper tool actually grabs the top part of the pallet to separate it. And then it's going to do the little melt phase, and then it opens up, the heated tool gets out of the way, and we bring it together to the seal phase. And then when you're done, that welded pallet comes up the front, as Rob's saying. Okay.
So, yeah, it's we've done many of these machines. Like I said, we've got over 260 hot plate welders out there in the marketplace. So not just of pallet welding, but it is something we do. That's what Xtol is. We're usually running about less than 1% scrap on these. I think that scrap, like Jason said before, usually there's something involved in that with a, short ship or something like that that goes into that.
Yep.
But, when you look at increased throughput, this is actually, I said, 4-axis servo system is usually what we have on some of those applications. That this other one that we're going to talk about is a 7-axis. It's going to have a very durable 6x6 steel tubular frame. And we've also designed it when you look at flexibility for changing those tools out. It's got a door that opens at the top. You can actually remove it from the side too, but it's a lot easier just to hook it up to a crane, lift it out of the top, and take that back out. So we can configure that for future flexibility.
Yep, and you can weld lots of different pallet designs all with one piece of capital equipment. Precise process control. So servo, I've touted how much control we have. As what we really, really care about, how you tune your weld and optimize it, is heat and pressure. So in the melt and open phases, the melt phase, we're controlling how much heat is going into the weld. The open phase is how much heat we're losing, so we want to minimize that. And then in the seal phase, how much pressure is going into the weld. So what kind of parameters does Xtol's welder give you? A whole bunch of them. And I did this because I wanted you to feel a little bit overwhelmed of like, wow, that's a lot of parameters. But don't worry, because, and this doesn't actually even show them all, there's also pass-fail criteria that you can, little windows of what's good, what's bad around a lot of these. So you get control over your weld process. But what really matters is a few parameters. These are the ones that actually make a big difference on the strength of your part and the quality of your parts. All of these other parameters, yes, need to be set. And of course, there's defaults. But Xtol, as Rob said, Xtol develops the recipe for you. So you come to Xtol to do the runoff on your equipment, and we've got this thing ready to go. And we weld parts, and then when we ship it to your facility, we make sure we come down with the machine and we make sure that it's going to weld parts correctly there. So whether that means you have warm parts from a molding process and we need to tweak some of the parameters, we help you with that. So you don't have to get overwhelmed by, oh my goodness, there's a lot of parameters. Yes, there are, but this gives you the control to be able to tweak every single thing that might need to be tweaked.
Right. Great summary. So just in a pallet welder kind of a cell layout, here's an example of a front load and a rear unload here. So I don't know if yours can point out this a little bit here.
Yes.
So just high level, you got your injection mold machine here, right? We're taking the part out of the injection mold machine. Usually that robot and that injection mold machine, that's the injection molder, right? They're going to say, what tool do I need on the end of this to get it out of the injection molder? And then what I need to do is I need to rotate that over to the rod load. If you do have rod loads, or you got those places where you might take both of those parts and set them directly in front of the welder, right? So there's going to be there's the load position there. It's going to shuttle back into the machine. You've got your hot plate there. This also goes to show if you wanted to do something with IR, be the same thing. It's just an IR tool.
Yep.
Right. And then what happens is once that weld is complete, then the pallets are shuttling out the back. There's a secondary conveyor, and you may stack those up. You may have a robot that stacks those or gets it ready for fork truck pickup. But really what we're focused on here is, where that rod load station would be there. We're taking it from that point to get it into the welder in the load position and then through that cycle and out.
Yep.
When you look at materials, if you're looking at a Polypro pallet, you're looking at cycle time about the same, really about 55 seconds. And the temperature might be 640 to 680 degrees. Force really depends on the weld design, but really we can go 5,000 to 8,000 pounds of force on that. So it's going to give you a really strong part. When you move to an HDPE, you're going to have a Teflon coated tool, right? Teflon coating means they do wear out the Teflon over time. It makes sense to have other tools there so you can ship that Teflon out to be recoated, right? Cycle time's about the same. The temperature, though, is going to be significantly less in this because really that Probably that sensitive zone for Teflon is probably in the 500 to 525 range. So you want to keep below that. And the force can be about the same.
Mm-hmm.
So when we're looking at that for pallet welding in a traditional sense with hot plate, that's kind of what something like that would work out. And we talk to you about what are some of your objectives for that, and how might we customize that for design. You can accommodate also different size pallets in that just by adjusting the tool. We just need to make the frame is big enough to accept it.
Mike asked, what's the most common puck material for polypropylene? Both of these would use a steel, typically a steel puck or plate, depending on the configuration. But so you're using steel for the actual heated tooling, and then the coating for polypropylene, you can actually go with either Teflon based. You'd have to limit the amount of temperature you put into that because Teflon starts to break down around 550, 600 degrees Fahrenheit. If you're going to weld at the elevated temperature, then we would go with more of a chromium-based coating, and that is a very hard, robust coating that is capable of withstanding super elevated temperatures, well above the 680 degrees Fahrenheit that we typically would use.
So one of the other inquiries we've had from people is, hey, we've got a pallet, we'd like to actually extend it, horizontally. Well, what can we do with that? We've talked it basically. I don't have an image of it here, but we basically take that hot plate and put it on a vertical.
Yep.
Right. So we would be welding. You could take this. Generally, these pallets get cut, right, and then they get welded together. So
you'd probably do like a quick cut right there and a quick cut right there, and then Shazam! You weld it.
Weld that together. So, obviously you guys need to be worried about what the structure is going to be like underneath that. That is something that we can do. We've done complex vertical welders. I think probably what I saw most for we did was for center consoles and automobiles, right?
Yes. Yep.
So
with a pallet, the welder is probably a lot simpler because it doesn't have, I wouldn't expect to have all these crazy complex geometries. It's a very straight weld typically.
Yeah. So we can do that. We can do that for totes as well, if that's something. Generally, these aren't high volumes when you're doing those type of things. But if it is something that you need to look at, then that's certainly something Xtol. That's that customization piece that we can also help you out with.
And it allows you to be a custom provider of pallets. So you can make, if your customer is asking for a certain size, now if you have the ability to cut and weld together, you can hit whatever dimension your customer's looking for.
Right. So we're coming up on our time schedule here. So we talked about hot plate welding. How does it work? What are the benefits? When is it used and how to design? And what does the equipment look like? Right. We also talked a little bit about IR. Mm-hmm. We didn't really get into so much for bin welding, but if you do have a bin that you're dealing with, if it's large or even a tote, right, we're also looking at other applications. We might be able to get a tote, depending on the size of it, into one of our standard hot plate welders. What we just have to worry about is the vertical clearance that we can get those parts in. But that's not a problem. We do those type of things all the time. Really.
Yeah. And if we were going to we have done some bin extension where you're increasing the height. The size of larger bins often necessitates a weld that's similar to the pallet one that we were looking at. But maybe that front load looks a little bit different. Because you've got the large bin on the bottom, and then you're adding some height to the top.
Yeah, great point. Looks like Willis is typing something. What's the most...
Yeah. What's your experience of parts produced via the low pressure structural foam molding process? Do you have the answer to that one?
I don't have the answer to that one.
Okay,
Jason.
So I guess, Mike, if you could explain a little bit more for me. I believe the structural foam typically has still some more dense material on the edges. Is that correct? Like, would you be able to get a sacrificial rib molded into something like that? If so, if you can get a sacrificial rib onto that top surface, then hot plate welding should be doable. But I don't know that once you get to the more porous part of the foam area, then the amount of plastic that we have available for welding, you'd really probably struggle to get any kind of a strength out of it.
Yeah. I'm just going to get to our last slide here. So we're right at 11:45. So I'm going to get my 30 seconds in. Mm-hmm. If you want help, you want to talk about an application, that's what we do. Okay. If we're looking at parts, doing an evaluation of your design, that's a free service that we offer. So feel free to send me an email or give us a call. We'll discuss your next project. We can make a plan. We would review your design. We can test your parts. We can offer some recommendations when it's, weld rib design or whatever, and also discuss equipment options.
Yeah.
That's just really what we do. But Will's got another question here.
Yeah. Do you have a Teflon with a higher resistance to heat than the green Teflon coated? I don't believe so. There's a few different Teflons out there that we have used, but all of them have Teflon at the core, and Teflon is the issue. Teflon itself isn't able to withstand very elevated temperatures above like that 550 Fahrenheit range.
Yeah. We'd love to talk about the application.
Do you know of one, Willis?
Yeah.
Was that a loaded question? Do you have one that we could use? Because we would love to hear about it if you do.
If you don't want to share, you can just call us and tell us.
Yeah, exactly. Maybe you don't want to. Maybe I've got competitors on the call here. Is there a minimum wall thickness needed? How deep does a weld go into a part? Great question. So we actually were having this discussion with another customer yesterday about how big of a weld rib do we need to add to this part to get it so we can weld it. And I said 3 millimeters on both sides, so top and bottom. You'd need 3 millimeters each. And then our lab manager said 2, and then he was like, well, maybe 2 or 3 millimeters. He was trying to.
Yeah, he was just trying to offer.
But basically, 3 millimeters, close to 1/8 of an inch. That's about the size that you would need. It really actually comes down to how flat or how close to flat are your parts. If there's a lot of variation in the flatness of your parts, and it's, we can pull some of that warp out with tooling. We hold those parts flat and we hold them into the tooling tightly. But if there's still some inconsistencies because of sink or knit lines on the surface, we want to melt those away. So if there's a lot of those, then we might have to melt a little bit more. But usually 2 to 3 millimeters at least of a weld rib, that would give you a good starting point.
And Will just said, no, I don't know, but it burns pretty often.
Oh, yeah. Yeah. And then you got to go send it out, get recoated. Typically the recoating process looks like you'd have a set of spare hot plate welding pucks or tools, and then you'd swap those out so that production can keep running. And then you take the ones that need recoating, send those to get them stripped and recoated.
Yeah. So we're still open for questions. We always do plan a little 15 minutes on the end of these just to answer those things. So please keep them coming. But we appreciate you joining us. Again, if you want to come out and visit us, we'd love to have you.
Yeah.
We enjoy helping out with clients and trying to take their difficult problems. That's usually what our team really likes to do, is something we haven't seen before. Give us a challenge.
Yeah.
Yes.
And I don't know if there's a lot of people on the call that would be interested in a staking webinar, but we are going to be talking about nanostake next month in our next webinar.
Yeah. So tune in for those webinars, because we do have one once a month, usually on a different type of welding technology. There's always something to learn with that. But if you just want to reach out, we also did some office hours,
yes,
which was pretty cool. First thing earlier this week.
So we'll probably, we did two events in the same week. We'll probably try to separate those to give people more chances to ask questions. Mark said, doesn't chromium make a better long-term, lower maintenance solution? Absolutely it does. The challenge with chromium, though, is its effectiveness with HDPE. It doesn't, HDPE is going to stick. At least that's our experience, is HDPE still sticks to chromium, whereas Teflon actually does give it some non-stick relief. So polypropylene and chromium, that's a great solution. But HDPE with chromium is not great.
Yeah, and Yakuin said, he said, what about how long does that last? I'd have to ask the lab on that.
Yeah, there's some things that can, prolong the life. You can make sure that this is another benefit of a servo welder. We have a lot of control over that approach speed. So we bring the parts close to the heated tool very quickly to, reduce cycle time. But we can ease it into the tool, ease it into that coated Teflon, and that allows to lower the impact and reduce the amount of wear that you see. I think, man, it does vary a lot as far as how often they need to be replaced. If I had to guess, our customers are probably replacing them every few months.
Yeah. But
maybe it's more frequent than that. Maybe it's a little less frequent. Does anybody on the call know the answer? Like, what are you experiencing for maintenance? How often do you have to replace your Teflon coated your tools? Be curious to know what.
All right.
Willis
Willis got another one.
Maybe he's going to answer the question.
Yes, and thank you so much for the participation. It's always good to have some questions. We want to make it relevant to you guys. So
At least once a month.
Okay.
Good to know. Thank you.
Thank you. But Willis is also burning his out. So
Yeah, so
Maybe
I don't know if you really want to trust Willis.
just kidding. But maybe you just need some better controls on that. We can help you out with that.
Mm-hmm. Real quick, is anyone interested in having somebody from Extol come on site and do training for the rest of your team? I don't know, maybe you've got your whole team on this
Great
call,
point.
but if you want us to come on site, that's something that we do pretty regularly. We're happy to travel to your facility, take a look at what you've got going on and talk with your team, explain hot plate welding. And we keep those very interactive, just like these webinars. So let us know if that's something you're interested in.
Yep. All right. If there aren't any other questions, we'll wrap up for the day. Thank you for attending. We look forward to working with you on a project in the future.
Yeah. Thanks, everybody. Have a good one.
Thanks.